I'm Greg Garfin. I'm a associate professor in the School of Natural Resources and the Environment here at the University of Arizona, and I'm also one of the deputy directors of the Institute of the Environment. And it's my pleasure to welcome you this evening to hear a talk by Dr. Katharine Hayhoe. I wanted to start with a few acknowledgments before I introduce Katharine. I would like to acknowledge Diana Liverman, Regents Professor in the School of Geography and Development here, and of course, a highly accomplished scientist on climate change, environment, and social justice. I would like to thank her for the generosity for helping funding this event and also for her time and vision. And I'd also like to thank the staff of the Institute of the Environment who arranged multiple aspects of the logistics for the event, in particular Tina Gargis, Angie Brown, Abby Cole, and Maggie Hurd, and also our graphic design wizard, Colleen Loomis, who made this wonderful image, and also Laura James of Atmospheric Research in Lubbock, Texas, who does a lot of the logistics for Katharine. The University of Arizona sponsors for this event are the Climate Justice Network, the Institute of the Environment, the Center for Climate Adaptation Science and Solutions, the Carson Scholars Program, and the Agnes Nelms Howry Program in Environment and Social Justice. And then I would like to thank a few organizations in the Tucson community that promoted the event: the Citizens Climate Lobby, Sustainable Tucson, and For Tucson. So I hope you've noticed, and if not, I'll point them out. At the ends of these tables, there are index cards so that you can write questions for Katharine. We will probably wrap up the event at 8:15, but something like a half an hour before then, folks will be collecting the index cards. So you'll want to get your questions in by 8:40, 7:40, 7:45, something like that. So Diana Liverman and I have been batting around emails with Katharine for about a year, aiming to find a time when we could all synchronize our schedules. So I'm particularly happy that Katharine was able to make it, especially at a time when the weather's lovely here. And I've had the privilege of working on a small project with Katharine. I'd just say it's been a real pleasure because she's upbeat and energetic and sincere. I could probably speak for at least an hour on Katharine's many accomplishments, but I won't. For example, I won't mention that she's been named one of Time's 100 most influential people, or Foreign Policy's 100 leading global thinkers, and I'll certainly not mention her more than 120 peer-reviewed papers. I'm just going to stick to the facts and talk about what's important. So starting with the facts, Katharine Hayhoe is a professor and director of the Climate Science Center at Texas Tech University. She's an atmospheric scientist and physicist whose research focuses on developing and applying high-resolution climate projections to understand what climate change means for people and the natural environment. So think about that. She's doing this to understand what climate change means for people and the environment. And that's what's important. And what's also important to me, anyway, is that Katharine has used the fullness of her life as a secular scientist and as a practicing Christian to explore issues of science, faith, and values related to climate change. And this mix of issues is important because citizen engagement on climate change is critical. And if you're interested in that particular intersection, then I'll mention that Katharine and her husband, Andrew Farley, wrote a book called A Climate for Change, Global Warming Facts for Faith-Based Decisions. And for those who look forward to something new, Katharine's producing a new PBS Digital Studios short series called Global Weirding, Climate, Politics, and Religion. And with that, it's my great pleasure to introduce the hardest working woman in the climate science world, Dr. Katharine Hayhoe.
Can't believe you did that. Thank you for that introduction, Greg. And thank you, everybody, for coming tonight. This is the first time I've ever presented with 3 screens. So you have no excuse. You look left, you look right, you are going to see this screen wherever you look. As Greg said, there's question cards there at the back. If you have questions as you go along, feel free to jot them down. This is also going to be recorded. So if you feel like you want to share this with somebody later on, or you feel like you need to go back and watch part of it, it is going to be recorded and made available. Talking climate. It's tough. And it's especially tough because when we hear people talking about climate in the public sphere, this is often what we hear them saying. I'm going to share some things with you that we have probably heard our politicians say about climate. Trying to pick some Arizona examples for you. Our planet has warmed and cooled since the beginning of time. For everyone who thinks it's warming, I can find somebody who thinks it isn't. You can understand I had to pick and choose from a lot of quotes here. I live in Texas. There are a substantial number of scientists who have manipulated the data so they have the dollars rolling in. There's many of us here in this room who would like to know where those dollars are. Yeah. These global warming studies are just a bunch of snake oil science. And the bottom line is that climate change is not science, it's a religion. For the proof, all we have to do is look to the internet, because as you know, the internet is the proof for everything. And if you have good eyes, you'll notice that somebody's actually photoshopped my head onto the choir. The bottom line, some may say, is that God is still up there, and the arrogance of people to think that we human beings would be able to change what he is doing to the climate is, to me, outrageous. When we see people saying this, the number one request I get, and people ask me this every week and sometimes almost every day, is, can you please explain the science to my neighbor or my uncle or my member of Congress or my mayor? Because if you do, I'm sure they'll get it. And unfortunately, the answer is they won't. Why not? Because isn't that normally the way we run our lives? If something isn't true, we find out it isn't true, and then we change our mind about something. That may be the way we think we run our lives, but actually, at least in some aspect of our lives, every single one of us does something that is irrational. You may have an irrational fear of sharks, when actually cows kill many more people than sharks. You may have an irrational belief about something being good or bad for you. And often, these beliefs are not that harmful. They don't really affect us very much. But today, we have these beliefs going around about climate change, which I happen to think is the biggest challenge facing our world today. And these beliefs can be very harmful. You may say, but hang on a second. Don't we have facts on climate? Yes. So we're going to take a little digression first and talk about the facts that we do have, so you know what they are, because facts are important. Whether you believe in gravity or not, if you step off the cliff, you are going down. Whether you think climate is changing or not, it is, and there are serious impacts. So let's talk first of all about what are the facts, and then let's talk about, well, if they don't change anybody's minds, how can we talk about this issue? What are the facts on climate? I've got 4 of them for you. The first fact is that climate is changing. Now, I'm not talking about weather. Weather is what happens in a certain place at a certain time. It's like a single tree. Weather is that crazy hot day when you literally fried an egg on the sidewalk. Or that day when it snowed. Or that incredible haboob. Or even the huge drought. That's weather. We're not talking about weather change, we're talking about climate change. Climate is the long-term average of weather over at least 20 to 30 years. It's like the forest. So saying, for example, that it's snowing in New York City, I'd like a little global warming now, please. And you may say, well, who said that? I'll give you one clue. It's freezing and snowing in New York, we need global warming. Is like saying, I'm on the Titanic and it can't be sinking because my end just went 200 feet up in the air. We're talking about the large-scale change over the entire planet over multiple decades. And when we look at global average temperature, which is the temperature of our atmosphere measured at 2 meters above the ground by tens of thousands of thermometers around the entire world, we see that, yeah, it goes up and down from year to year. Some years are colder, some years are warmer. Last year happened to be the warmest year on record. 2015 was the warmest before that. 2014 was the warmest before that. But will 2017 be the warmest year on record next? I actually don't think so. I think it'll probably go down a little bit. That's weather. But over climate timescales of 20 to 30 years, we see that global temperature continues to increase. And it isn't just about temperature. The evidence surrounds us. Whether it's record-breaking heat waves in Australia, whether it's stronger hurricanes in the Gulf, whether it's increasing risk of heavy precipitation, or stronger droughts in a warmer world. If we look around the entire planet, we could throw out every thermometer. We could throw out every satellite instrument. We could throw out every scientific observation, and in the natural world, some of the evidence in our own backyards, we would find over 26,500 indicators of a changing climate. Peach trees in Lubbock, Texas, flowering 3 to 4 weeks earlier in the year than they were 30 years ago. Fire ants much farther north than they ever have been before. Invasive species moving poleward. Endangered species moving up the mountain. Glaciers melting, sea level rising. We're seeing the changes all around. Climate is changing, and that is a fact. What's the second fact? The second fact is that for the first time in the history of this planet, it really is us. Now you might say, hang on a second, I know that climate's changed before. And it has. And you know who studies past climate changes? Climate scientists. In fact, I would venture to say there's more climate scientists that study past changes and natural variability than actually study human influence. I haven't run the numbers, but I'm willing to bet. So when you say it's just a natural cycle or it could be the sun, we say, well, we can study that and we have information. First of all, we can cross off the middle one, right? Because we're not trying to predict the weather, are we? We're trying to predict the long-term trends over 20 to 30 years. So we know that it's not weather, we know it's climate. But let's look at the sun next. So if our planet were getting warmer because of changes in energy from the sun, which has definitely happened before, does that mean that the sun's energy would have to be going up to make us warmer or going down to make us warmer? Anybody going to vote with their thumbs? Yes, up. Good job. So this is the Earth's temperature over the last 60 years or so. The wiggly line is the year-to-year stuff, and then the thick line is the long-term average. Now let's look at the sun's energy. The sun has an 11-year sunspot cycle. That's that big swing from year to year. But long-term, the sun's energy has actually gone down a little bit. So it can't be the sun causing us to warm, because if the sun were controlling our temperature right now, we'd be getting cooler, not warmer. The sun's helping us out. If it isn't the sun, could it be natural cycles? We have two types of natural cycles in the climate system. The first are natural cycles that occur inside the climate system. They act like a teeter-totter or a seesaw. Now, I'm kind of curious. How many people call this a teeter-totter? Okay, seesaw? Oh, mostly seesaw. I would go with about 2/3 seesaw. It's interesting because I have never found anywhere, I don't ask this all the time, but I've never found anywhere where most people answered one over the other, except Utah. Apparently, teeter-totter is the Mormon version. I didn't know that. So, whatever you call this is a good analogy for how natural cycles work. They move heat from the ocean into the atmosphere, from the atmosphere back into the ocean. They bring patterns of wet and dry, hot and cold. But if our atmosphere, measured by thousands of thermometers around the world, if our atmosphere were warming consistently, not just year by year, but decade by decade, due to natural cycle, that heat would have to be coming from somewhere. And there's really only one place it could be coming from, and that's the ocean. So rather than looking at the temperature, let's look at the heat content. Because if the heat content of the atmosphere is going up, and the heat content of the ocean is going down, then that's where the heat's coming from. Here it is. What are you looking at here? The green is the increase in the heat content, not just of the atmosphere, but the land and the ice also. And the blue is the increase in the heat content of the ocean. Did you know that more than 90% of the excess heat going into the climate system over the past 50 years or so has gone into the ocean? When we use thermometers to measure global warming, we are literally measuring the tip of the iceberg of global warming. This can't be just a natural cycle moving heat around the Earth system. The entire thing is warming. Now, you might say, but hang on a second, though. I know there's another type of natural cycle. How do you know about this other type of natural cycle? Because you watch the Ice Age movies. Anybody will confess to watching the Ice Age movies? Yes. Anybody has had to watch them multiple times? Small children? Yes. What's the Ice Age movie about? It's about the fact that our planet used to be covered in a large amount of ice, more than a mile thick, and almost all of that ice melted. So it used to be very cold, and now it's warm. So could it be that we are just warming after the last ice age? That's a reasonable question. If we look at the data, though, we see that warming after the last ice age peaked about 6,000 to 8,000 years ago. And if we look over the course of human history on this planet, if we look at human civilization, our civilization has not been around that long. If we look over the course of human civilization, we see something very interesting. Our Earth's temperature was quite stable, but if anything, it was going what? Slightly down. You know why it was going down? Because according to the position of the Earth's orbit, which is what causes these big ice age cycles, changes in the tilt of the Earth's orbit, changes in the eccentricity of the orbit, becoming more elliptical and more circular, changes in the precession of the orbit. These changes are what bring the ice ages, and you can calculate using mathematics where we are in that cycle. And according to where we are in that cycle, guess what should be happening? Another ice age. We should be heading into the next ice age right now, and we are not. And that's a good thing. I don't know about you. I'm from Canada. We wouldn't have a country if there was another ice age. I don't want to head into another ice age, but as you've noticed, we are heading very quickly in the opposite direction. And I've put something else on this map too. It isn't just about temperature, I've put something else here. Carbon dioxide, a heat-trapping gas, because it gives us a big clue. Carbon dioxide levels were quite stable until all of a sudden they started to go up, and it happened at the same time as temperature started to go up. Now, just because they're happening at the same time doesn't mean they're related, but it gives us a clue. Before we can go on, though, we have to conclude that our natural suspects have an alibi this time. It can't be the sun, because if it were, we'd be getting cooler right now, not warmer. It can't be natural cycles inside the Earth's system, because the whole planet is warming, the ocean more than anything. And it can't be the Earth's orbit, because according to that, the next thing coming was an ice age. Only then can we look to another reason. And when we look, the answer doesn't take long to find. We know that when we burn coal and gas and oil, it produces carbon dioxide. We know that we've been burning a lot of it since the Industrial Revolution. Why? Because we figured out how to power our transportation, how to power electricity, how to power factories using fossil fuels. And for many of us, the Industrial Revolution was a good thing. I don't know about you, but I'm not a big fan of those shows where you go back in time and you have to live like 300 years ago. No electricity, oil lamps, dying an early death of things that nobody should die of in the 21st century. There's tremendous advances that came with the Industrial Revolution, but they came at a price. And the price was the fact that we powered the Industrial Revolution by burning massive amounts of coal and gas and oil. Why does this matter? Let's see if we can make this work. Yes. It matters because our planet, there's our planet already had a natural blanket of heat-trapping gases, carbon dioxide, methane, water vapor. The sun's energy shines down on the Earth. The Earth heats up and gives off heat energy just like you would under a blanket, and that amazing natural blanket traps the Earth's heat, keeping us almost 60 degrees Fahrenheit warmer than we would be without that natural blanket. We would not have life on Earth if it wasn't for this blanket. Well, if it's natural, what's the problem? The problem is that by digging up massive amounts of coal and gas and oil and burning it, we are wrapping an extra blanket around the planet that it did not need. And just like you would if you were asleep and your grandma snuck in and put an extra blanket on you, and you wake up in the middle of the night and you say, "Grandma, I didn't need that blanket, I'm sweating." That's what's happening to our planet. Our planet is running a fever. Now, you might say, that's all well and good, but I know this is some newfangled science you're presenting. And we're just not sure about this science yet. As we saw from the quotes, for every person who can tell you it's warming, I can find somebody who says it isn't. Maybe we need to wait a little bit longer until the science is more solid. Well, here's a picture of the people, the scientists, who made all the discoveries that I just talked about right now. And these are their real pictures. These are not those fake pictures where people dress up in old-timey outfits with their families. The Wild West pictures. Do you do them here? Yes. Okay. These are the real pictures. Joseph Fourier, familiar to any of you who do math and engineering. In his free time, apparently they had a lot of free time in those days, he decided he was going to figure out why the planet was a lot warmer than it should be. He's the one who discovered that we have this natural blanket. John Tyndall, a British scientist, was the one who figured out in the 1850s that burning coal and gas and oil was wrapping an extra blanket around the planet. The lives of these men are fascinating. John, later in life, had trouble sleeping, and so his wife would give him sleeping draughts of chloral. One night, she accidentally mixed the wrong proportions. His last words were, "Louisa, you have poisoned your John." True story. Arrhenius was a Nobel Prize-winning physical chemist. In his spare time, literally, he decided he was going to, by hand, calculate the first climate model in 1890. Using physics he knew in 1890, he calculated how much the world would warm if we doubled or tripled levels of carbon dioxide in the atmosphere. He even calculated how much faster the Arctic would warm than the rest of the world. And you know what? He was right. About halfway through his calculations, they took him 2 years by hand, his wife packed up the family and left. I know. I took this personally because I am a climate modeler too, but we use computers these days. So I set up my simulations on the computer, I push the button, I go have dinner with my family. I might check on them at 2 in the morning, but they don't have to know that. So the facts are that climate is changing, it is us, and the third fact is, it is bad. The impacts are serious. Why do we have such a problem with this? If you had to design the cover for a book on global warming, or if you were looking for a book on global warming in the bookstore, what is the #1 image on the cover of that book? Thank you, exactly, a polar bear. Preferably one that's looking kind of lonely and sad, sometimes sitting on a piece of melting ice. And because the polar bear is the #1 symbol of global warming, and because most of us have not been so fortunate as to actually see a polar bear in the wild, and even if we have, it's not where we live, it makes this issue seem remote and distant, doesn't it? The reality is we care about what the polar bear is telling us because if we don't heed its warning, we're next. Not quite as literally as this man here. He did make it safely into the car, if you're wondering. Why do we care about a changing climate? We care about it because our society, our infrastructure, our economic system is predicated on an assumption that we hardly ever think about. It's the assumption, though, that we can have heat and cold, we can have wet and dry, that's weather. But over climate timescales, we assume it all averages out. What am I talking about? Building codes. Where do we get our building codes from? Looking backwards in time. What about flood zones? Looking backwards in time. What about the drought of record? Looking backwards in time. And that works great if climate is stable. But what happens if it isn't stable? And even worse, what happens if the variability is changing? We will have built a building that is no longer suited for the place in which it stands. We will have a flood zone that no longer protects people from the risk of flood. We will have plans in place for the drought of record, which is exceeded again and again and again. We care about a changing climate because it affects us, and we have built our civilization as if we were driving down a highway in West Texas. This is where I live. This is really what it looks like. And there are very straight roads where I live. In fact, there are some roads like I-27 that are so straight that you could drive quite a ways down the road, going along, staying in your lane, looking in your rear view mirror. Why? Because the road is so straight that where you were in the past is a perfect predictor of where you'll be in the future. But just before you get to the next town up there called Plainview, there is this. That is a giant curve in the road with a row of concrete silos on the curve. What happens if you are driving along this arrow straight road looking in your rear view mirror and you get to the curve? I hope you know. Okay, good. Don't want to collect any driver's licenses at the door. You have a bad accident because you end up in a very different place from where you're planning to be. And this, to me, is the perfect metaphor of our society and our civilization. If we are planning looking entirely backwards, now backwards certainly has value, but if we are planning looking entirely backwards in a changing climate, we will end up in a completely different place than we intended to be. Planning for the future based on the past is like driving down the road looking in the rear view mirror. The changes that we are seeing today are impacting our water resources. They're impacting our food. They're affecting national security. And they're even affecting the economy. We care about a changing climate not because it's some environmental issue, not because it's some tree hugger issue, not even because we care about the polar bears. We care about a changing climate because it exacerbates the risks we already face today. This is so important, I'm going to say it one more time. We care about a changing climate because it exacerbates the risks we already face today. What risks do we face right here in Arizona today? Water issues, exactly. But there's other more insidious issues that are also exacerbated by a changing climate. Socioeconomic disparities. disproportionate vulnerabilities to extreme events, people who can't afford to buy a nice house in a nice part of town, so they live next to the freeway where the air pollution is already high and getting higher as it gets warmer. You see, there's all of these social and economic issues wrapped up in a changing climate. And that's why I love this series so much. If you haven't seen it, you should check it out. The Years of Living Dangerously. In season 1, they go around and they talk to real people who are being impacted by a changing climate. They put real faces on it, because it is already serious. And the fourth and last thing we know in terms of our facts are that scientists agree on this and we're lowballing you. Now, you might say, and in fact, somebody just said yesterday, I don't know if you saw this in the news, yesterday at a town hall meeting in Mesa, Andy Biggs said, there are credible scientists who say climate change exists. We aren't sure why. I wasn't sure if that actually means we aren't sure why it exists or we aren't sure why they say that. There are credible scientists who say climate change exists. We aren't sure why. And there are credible scientists who say it doesn't. So there's a team at George Mason University that does what they call message testing. And a couple of years ago, they spent the summer in the national parks across the country talking to people, telling them one-line, simple statements about climate change, and then asking people if it made them change their mind about it. And what was fascinating to me is the number one single sentence that changed the most people's minds about climate change was, guess what? Scientists agree. Because when you ask people, do you think scientists agree? 45% of people think we do, and 55% think we don't. Why so many people? Because every time you turn on the television, what do you see? You see one head saying it's real and the second head saying it's not. You say one head saying it's proven, and then you see the other head saying it's not. Why? Because that's the way our television works. It isn't interesting if you have two heads agreeing with each other. And so after I heard that the simple message, scientists agree, is the number one most impactful short message you can give people, after that I decided it is actually irresponsible for me, and this is a personal decision, I'm not extending this to anybody else, but I decided for myself, I feel it's irresponsible for me to do one-on-one head-to-head, because I am actually promoting the myth that it's 50-50 by doing so. Now, yes, do we still have to stand up for the truth? Absolutely. Is it important to get out there and say, hey, that's not true? Yes. But it's really fascinating to consider the role the media has played in enhancing this idea that we're 50-50, when the reality is that study after study has showed that we're more than 97% in agreement. So you said, okay, scientists agree, but what was the second part of the fact? Scientists agree, and we are theirs. A few people got it. We are lowballing you. A couple of years ago, my program director, a man who's very supportive of what I do and agrees that climate change is real, he came up to me, he said, you know, Katharine, I have a piece of advice for you and your colleagues. I said, okay. He said, if you could just kind of share with them to not be so alarmist in their predictions. You know, a lot of the flack you get is because you're always saying all these terrible things are going to happen, and you're just taking it a bit too far. If you could just dial it back a little bit, I think you'd get more credibility. And he meant very well. He really meant well by saying that. We hear this again and again and again, and I'm going to give you a quote from last week. Alarmist predictions amount to nothing more than wild guesses. Their ultimate goal is to promote a personal agenda, even if the evidence doesn't support it. So where does the idea that scientists are alarmists come from? It comes from people calling us alarmist. And so what I love about social science is that social science can actually tackle some of these questions. And so a few years ago, Naomi Oreskes, who you might know from Merchants of Doubt, it's a really good book and a movie if you haven't heard of that, Merchants of Doubt, she and her colleagues decided they were going to write a paper and do a study where they actually quantitatively measured if we're alarmist or not. The paper started off by saying skeptics of the reality and significance of anthropogenic climate change have frequently accused climate scientists of alarmism. As you can see, they certainly have. And so what she and her colleagues did was brilliant. They took from 1990 to 2010, 20 years of time over which we have very good data and we had very good climate projections. And they said, we're going to look across the whole world. We're going to look at sea level rise and temperature, glaciers and forests, northern hemisphere and southern hemisphere, ocean and atmosphere. We're going to look across the whole planet, and we're going to actually compare what really happened in those 20 years with what scientists predicted would happen. And what I expected them to find was that, some studies might be too high, some studies might be too low, but I expected that they would find that we were actually right on the money. Because as scientists, we are trained and taught to be as unbiased as possible. And that is not what they found. The available evidence, they said, suggests that scientists have actually been conservative in their projections of climate change, meaning specifically that we are biased towards being too cautious. And they even coined a syndrome, ESLD, erring on the side of least drama. They found a consistent trend towards actually underestimating the rate of change or the magnitude of change. Not all the time, not everywhere. Why are we doing this subconsciously? It's not even conscious. It's because, at least in part, we hate to be called alarmists. We absolutely hate it because we are trained to be impartial and unbiased. And many of us are very cautious and conservative and very careful in the statements that we make. For me to make a statement publicly that has any number in it, I always have a reference or citation in my head to back myself up. We are not people who lightly step out and blithely say, throw out this number here or that number here. We have checked and cross-checked and submitted our work for peer review and had other people check it before we put it out there. So the facts are that climate is changing. It is us. It is serious and bad. And scientists agree. So now you might say, can you please explain this to my uncle, my college roommate, my mother-in-law, my neighbor, my member of Congress? Because if you do, I'm sure they'll get it. They have to get it now. Why won't this work? Because it's based on something called the science literacy or the knowledge deficit model. It's the idea that if we just present people with information, more and more and more and more information, they'll change their minds. If they don't have the right opinion, it's because they don't have enough information. And here's where the social science comes in again. This is a study by Dan Kahan. I like showing you the pictures. Doesn't it make it more personal? One way or another when you see who's talking. So this is Dan's paper. I love it because he said public apathy over climate change is often attributed to a deficit in comprehension. People just don't know enough. They know too little science to understand it or to avoid being misled. So if this is true, then what is the solution to a lack of public understanding of climate change? The solution is to write another report. So these were the 1990 IPCC reports. Working Group 1 is the physical science. Working Group 2 is the impacts. Working Group 3 are the technology and socioeconomic solutions. And maybe those weren't enough, so they wrote another set of reports a couple years later. 1995, a full set of new reports. Then the reports of the 2000s, 2005, most recent set of reports. Well, but those were international reports. Maybe we need a national climate assessment, or a second one, or a third one, or the fourth one that they're working on right now. Well, but those were government reports. What about an independent report from the National Academy of Sciences, or another report from the National Academy, or maybe another one? You get the point, right? Every report is better written than the last. Every report has a larger foundation of data than the past. They have colored figures. They have videos. They have movable graphics. They have interactive websites. But here's what Dan found. We tested this account, and we found no support. No support for what? What was he looking into? Whether more information would change people's minds. Members of the public with the highest degree of science literacy were not the most concerned about climate change. They were the most polarized. Is that crazy or what? We are not blank slates waiting to be written on by the next climate report that comes out. Even if we have the best writer in the world, even if we have the best graphic designer in the world, and don't get me wrong, I love good writers and graphic designers, but that is not what is going to change our minds. And Dan went on to say, this result suggests that public divisions stem not from incomprehension of the science, but from personal interest that people have in forming beliefs in line with those held by others with whom they share close ties. So there's many reasons why we decide on who it is that we're going to marry. We often decide based on similar cultural background, similar interests, something as shallow as appearance, race, gender. But did you know that for the last few years in the United States, the #1 predictor of who you will marry if you are not already married, the #1 predictor is simply how close you lie to each other on the political spectrum. In the United States, over the past 25 years, a radical change has taken place. In 1994, this is what the political landscape looked like in the United States. Democrats, Republicans, nice normal distributions, pretty close together. By 2011, it looked like this. By 2015, it looked like this. What happened? Two things. Number one, the averages, the means were moving further apart. But for those of us who look at distributions all the time, we see something even scarier. The shape of the distribution is becoming skewed towards the tails. And when you look only at people who are politically active, yeah, it looks even worse. What does this have to do with climate change? It has everything to do with climate change. Why? Because climate change for the last 3 or 4 years has been one of the most politically polarized issues in the entire United States, where the #1 predictor, not just of who you will marry, but what you think about climate change, is simply where you fall on the political spectrum. That is what predicts our opinion. If you look at the latest Pew survey, you will see that there are stark partisan differences. So the red circle on the left is the average Republican, and the independent is in the middle, and then the blue circle on the right is the average Democrat. The difference between Republicans and Democrats on questions about climate change are bigger than almost any other political issue today. So when we have our conversation about climate change, and Susie the scientist shows up with all of her facts and data and reports piled up to the ceiling, what does Calvin respond with? He does not respond with facts and data and logic. He responds with identity. And that is why these conversations will not build bridges, they will dig trenches, and they will inevitably end like this. I couldn't find a picture with both people's heads exploding, but I think that would have been more accurate. The real problem is not a problem with the science, because the science that we use in our climate models is the same science used to design airplanes and to run fridges. And last I checked, nobody really had a problem with refrigerators. Some people might have a problem with airlines, especially after what was happening in the last few days. But even still, we don't think they aren't real, right? The real problem is not a problem with the science. The real problem is a problem with solutions. But it's a lot easier to say to ourselves, as well as to other people, it isn't a real problem, than to say it is a real problem, but I don't want to fix it. One of the organizations that I work with a fair amount and that I respect a great deal is the National Association of Evangelicals. This may surprise you, but this is what their vice president had to say, and I think he just hit the nail on the head here. Galen Carey says, many evangelicals do oppose actions to slow climate change. It's absolutely true. But they do not do so on a religious basis, but rather politically because they believe the government wants to take away their freedom. And now, let's get it right from the horse's mouth. In 2012, the same year that he said this, the quote that we saw before about how arrogant it is of people to think that we can control something as big as this planet, same year he said, "Do you realize I was actually on your side of this issue when I was chairing the Senate Environment Committee and I first heard about this? I was on your side until when? Until I opened the Bible and read some verses about how climate change isn't real? No. Until I listened to the scientists and realized that the science wasn't real? No. I was on your side. I thought it must be true until I found out how much it would cost." He literally said this. Yes. And that is why I really think this is the most honest sign I've seen. I don't know why they have a problem with donkeys. This is a picture from Australia. I'm sure nobody would have a sign like that here. And so here's the thing. Even if we can't agree about the politics, we still can agree about solutions. Even if we can't agree about science, and if you look at the Yale Climate Communication Program's climate opinion maps, fascinating. You can break the results out by county and by congressional district. You look at this and you say, percentage of adults who think global warming is mostly caused by humans, anything that's blue is below 50%. You look at this and you go, wow, we have a serious problem across much of the country. We have to change this first before we can do anything else, right? That's often what we think. But guess what? They went on and they asked people other questions. Next question. Do you think, okay, so remember, this is, do you think humans are causing global warming? Look at all the blue area. Do you think global warming will harm people in developing countries? What just happened there? I might not think it's real, but yes, it is harming people. Okay, guess what? We have a basis that we can work together on here. We can work with developing countries to help them build resilience to a changing climate. Do you support requiring is mandatory, do you support requiring your utility to produce 20% of their energy from renewable sources? Guess what? Everybody does. Can you see a single blue congressional district there? I can't. Here's another one. Do you support setting, and this one's kind of crazy, do you support setting strict CO2 limits on coal-fired plants? It's particularly crazy considering what the EPA is considering doing right now. They're considering removing all the limits. Well, guess what? Everybody supports it. Isn't that amazing? And then, this is my favorite, do you support funding research into renewable energy? Guess what? That's like a big yes. So, how can we talk about this issue? I want to close with a few thoughts on this. 4 steps, to be precise. 4 facts on climate, 4 steps on how to talk about this. And they aren't necessarily what you think. First step, bonding over a value that we genuinely share with the person or the people that we're talking to. Then connecting the dots between that value and a changing climate. Only at that point, and this part is actually optional, only at that point doing any explaining if we need to, but always, always, always ending by talking about solutions that we can work together on to tackle this problem. What do I mean by each of these steps? I'm going to give you a brief example. What values do we share? Do we fish? I used to fish 4 hours a day, all summer long. Do we ski? Are we a parent? Are we a Rotarian? The 4-way test is a great one to apply to climate change. Are we a member of the Boy Scouts or the Girl Scouts? Are we part of a faith community? Are we just simply a human who lives in a certain place? Just about every single person on the planet already has all the values they need to care about a changing climate. Just about every single person. We just have to figure out what those are. And then once we've done that, given these shared values, why might we care about a changing climate? I care about climate change because our family does this on our vacations, and we are increasingly concerned that we might not do anymore. I care about a changing climate because it is affecting the bird populations, and we're birders. I care about it because I'm a city planner and I live in cities that are expanding rapidly and putting people at risk during heat waves. I care about it because I manage water in Texas and we never have enough to go around. These are just a few examples of how we can connect on this issue of climate. There's a million more. Some of them as basic as the fact that I'm a human and you are too. Others as nuanced as, I manage water in this certain district and I know the issues that we confront together. If we look around the United States, though, there is one thing that over 70% of people have in common, and that is a shared faith. And it's the Christian faith, it's the Jewish faith, and it's also the foundation of Hindu, Buddhist, and Muslim faith, a shared value of caring for people who have less than we do. And when we look around the world, we know that climate change disproportionately affects the most vulnerable people in the world. In Texas, they have their own translation of the Bible. They put it on road signs. I like this one. That love thy neighbor thing, I meant it. Sign God. Our faith is one of the biggest ways that we can connect on this issue of climate. The idea of caring for the poor. This is the Pope. Everybody knows about his encyclical, I hope. This is a report by the National Association of Evangelicals on loving the least of these, caring for climate change and the poor. Now, at this point, only if we need to, we can do some explaining. We can do some explaining on how it's us, it's real. It matters in the east because sea level is rising and stronger hurricanes are getting more frequent. It matters in the west because beetles are overwintering, eating our forests. It matters in the north because previously frozen ground is thawing and crumbling, falling into the ocean, putting over 200 Native American villages at risk in Alaska alone. It matters in the global south because heavy rainfall events are increasing. We can do some explaining if we want, but we always need to end by talking about solutions. Because the social sciences showed that as humans, if we feel like there is this intractable problem that we can never fix, what is our defense mechanism? Exactly. Shut down, disassociate, disengage, ignore, and even deny. That is why if we can do one thing, talking solutions is the most important thing. And guess what's the first step to that? It's actually opening our mouth and talking about it. This is the bluest map I've showed you. And you know what question they asked people? Do you talk about it? You know what? Over 75% of us don't. Why? Because we're scared it's going to end up like Calvin and Susie. And it will if we start with the facts and we end with the facts. But if we start with the heart, with our shared loves or fears, and we end with solutions, it can end well. It can end with agreeing to disagree on some things, but agreeing to agree on others. So what types of things can we talk about? Let me give you some examples. I talk about building resilience for a changing climate, whether it's replacing our old pivot irrigation systems with in-ground drip irrigation that doesn't waste so much water because water evaporates the hotter it gets, or whether it's the Netherlands where they're preparing for sea level rise by building floating villages. Sea level goes up 4 feet, who cares? You buy another 4 feet of anchor chain, you're good. I talk about how in Texas, shiny white wind turbines are replacing old rusting oil rigs. And how in Africa, they're not even building an electricity network, they're just putting in the panels already. In Texas, we have entire towns going renewable because it's the cheapest thing to do. We already get over 12% of our energy from wind, and it's up to 40% on a windy night. Fort Hood, the biggest military base in the US, that's a picture of them up there, they're going renewable to save taxpayers $165 million. I talk about China, because everybody says, oh, China. You know, we could do everything we could, but China's just going to mess us up anyways. Well, not anymore, because this is more what China looks like today. Yes, they still have air quality problems. Yes, living in Beijing still shortens your life by 5 years. But they know that, and that's why they have more wind and solar energy than the entire world, and they just announced they're going to be spending $360 billion in the next 3 years to make 13 million new jobs. in the clean energy industry. What else can we talk about? These are one of our little global weirding videos. We talk about things that we can do. I got a plug-in car this year. I was so excited. And you know what? All of our neighbors, who up until this point have just driven by in their enormous SUVs and sort of waved out the window, every single neighbor so far has stopped, gotten out of their car, and said, "What is that?" We explain, they look at it, they say, "Wow, it gets that mileage? Really? Oh, it's nice." It's a conversation starter about solutions. We can encourage our community to join, whether it's a church in Minnesota that offered its roof to the community as a solar garden, or tiny little Houghton College with 1,200 students in upstate New York that is the biggest solar array of any educational institution in the state. It's pretty impressive. There's organizations like Citizens Climate Lobby that helps us make our voices heard. Bottom line is, we can talk about climate. Don't be one of the 75% who don't. We can. We can talk about it by bonding over our shared values, connecting them to climate, doing some explaining then if we need to, but most of all, finding ways that we can act together. Because what really changes our minds about this issue is feeling like we can make a difference. We need hope to move forward. We need to come at this not just from our science perspective with our brain and our facts and our data, but as Jane Goodall said just this past year, she said, "It's only when our clever brain and our human heart work together in harmony that we can achieve our full potential." Thank you. And I should say, too, so on Facebook, we put our Global Weirding videos out on Facebook. They're not on television. They're on YouTube and Facebook. And every other week on Facebook, I actually do a live Q&A. I answer probably about 100 questions in about half an hour. And it's really fun. You can watch the past Q&As on my Facebook page, or you can join. They're on Thursday nights. The next one's next week. So if you didn't get your question in today.
So, one question is, what is your take on eco-theology?
Sure. That comes in many flavors and brands. But the bottom line is connecting what you believe to the planet. And what was amazing to me is to learn that just about every single major faith tradition has the concept in that of stewardship or responsibility for our home. And it's similar to what we would feel as a homeowner, right? We have responsibility for something that we have been entrusted with, but it's more than just an inanimate building. It is a living planet that supports all of us. And so as I talked about, connecting with our values is very important, and given that over 85% of us in this world belong to a faith tradition, and that the majority of those faith traditions do have a tradition of responsibility for this amazing world we live on and the people who live in it, I think that making that connection is absolutely key to understanding why it matters to us.
Why is climate variability growing?
Why is it growing?
Yeah.
Yes, in many places it is increasing. We are seeing changes in the shape of the distributions that look a lot like the political distributions. That's kind of weird. I wonder if there's any correlation between that. As the climate warms, we are seeing some of the biggest changes at the tails of the distribution. Why are we seeing more heavy rain events in a warmer planet? It's because as the world warms, evaporation rates speed up. More water evaporates out of the oceans as well as lakes and rivers. And so when a storm comes along, there's more water vapor up there for it to pick up and dump on us. Why are we seeing extreme heat days increase in many places? Part of that is just because the average is increasing, but part of it too is that our weather patterns are being affected. We are seeing, in many places, the weather getting weirder. And now you might say, hang on, but you said climate, not weather. Right. We have to add up the statistics, not just 1 year, not just 3 years, not just 5. We have to look at how the statistics are changing over 20 to 30 years, but we see that they are. And so that's part of the reason why we decided to call our series Global Weirding. It's because, the planet's warmed by a degree. We can't sense that degree. There's probably a degree difference between the front and the back of the room. But we can definitely see that things are getting stranger. And so that's often one of the first ways that we experience it in our lives today.
Do you think that geoengineering is going to become a prominent solution in the upcoming decades?
Ooh, that's a good question. So geoengineering is the idea of engineering the planet. And you might say that we are already conducting an unprecedented geoengineering experiment by wrapping this extra blanket around the planet. When people talk about geoengineering, though, they're usually talking about something that we're going to do now to reduce the impact of that blanket. Some of the steps can be extremely low tech. Did you know that large-scale tree planting is actually a form of geoengineering? Because you're planting all those trees to take all that carbon out of the atmosphere. But some types of geoengineering are much more high-tech, like what they call solar radiation management, which is a fancy term for trying to mimic the effect of a volcano on our planet. When a volcano explodes, it pushes enormous amounts of soot and dust up into the air. If it's a very powerful volcano, that soot and dust can get all the way up to the stratosphere, and it can go around the world for up to 2 years, acting like an umbrella over the planet, reflecting the sun's energy back to space, cooling down the planet. So people have been talking about, could we mimic that by shooting massive amounts of soot and dust up into the stratosphere to put an umbrella over the planet? And studies show that, yes, it would actually cool us off temporarily, but it would also massively cut the amount of incoming sunlight which our plants and crops need to grow. And it might not affect other changes like acidification in the ocean, changes in rainfall patterns. Basically, geoengineering is like as if everybody on the planet was running this low-grade but increasingly troubling fever, and we invented this drug that had never been tested before except in a theoretical model and in a very limited way, and we decided to administer this drug to every single person on the planet on the same day. It's a little bit scary, but at the same time, it's worth studying. Because as a scientist, I feel like, well, if someone's going to do it, I would like to know what's going to happen. But the ethics of this are huge. And this is a major area where we need ethicists thinking about this issue. What are the implications if we do this and something goes wrong? Who's going to suffer? People on this side of the world or that? People in future generations or today? Because you can't really reverse a lot of these things.
How do you deal with people whose faith dictates that this world was made for mankind, or that they are headed to heaven, or waiting for the second coming, and therefore don't see the need to protect this world?
The way I talk about those types of issues, and I hear them all the time, God's in control, so humans couldn't affect the planet. We have dominion over the planet, so we can do whatever we want to it, and it's all going to disappear anyway, so why does it matter? The response to those comes not from the science, but I respond to those actually directly from the Bible. In Genesis 1, it talks about how humans have responsibility or dominion or stewardship over the planet, and I talk about, well, what does it mean if you have dominion over a company and you run it into the ground? If you have stewardship of a farm and you extract every resource from it and you leave it a broken down heap, gets the point across. And then you can move on to Thessalonians, where people in Thessalonians, we humans never change. People back then, 2,000 years ago, were saying, oh, well, the world's going to end anyway, so I'm just going to quit my job and sit around. And the Apostle Paul wrote to them, he said, you do not know when that's going to happen, so in the meantime, you are called to get a job, support your family, care for the widows and the orphans, because we are called to love others while we are here, not sit around with our hands folded waiting for the world to end. So the effective response to those things does not come from the science. It comes from the same place where people believe their attitudes come from, but it turns out they don't actually.
Along similar lines, how much of an effect did the Pope's encyclical have on views about climate change in the faith-based community?
Oh, so the Pope's encyclical had a measured effect on public opinion in the United States. Ironically, it actually, I believe, changed more Protestant opinions than Catholic. Isn't that interesting? There was a positive Pope effect, but I want to show you something. I think I have it here. I want to show you something that really shows where the complexity of this issue. Let me see if I have it. Yes, I do. Oh, good. Okay. So I know the font's a little bit small here, but hopefully you can see it. This was a study done 2 years ago where they asked people, how concerned are you about a changing climate? All of Americans are the first line there, and then they divided people out by denomination, but they split the Catholics in half. The most concerned people group about climate change in the United States is who? Hispanic Catholics. Now run your eye down to the bottom of the list. Yeah. The bottom of the list is not white evangelicals anymore. It's white Catholics. And so you might say, but it's the same Pope. Yes, but what is the number one thing that determines your view on climate change today? Political affiliation. This shows that even though we often think that it's our faith that makes us doubt the reality of climate change because of the religiously sounding arguments that Greg just alluded to, those are smoke screens for the real issue. So when someone says it's just a natural cycle, smoke screen. When someone says the science isn't sure, smoke screen. When someone says God is in control, it would never happen, smoke screen. When someone says, I don't want the government telling me how to set my thermostat, real. That is the real reason, and I think this makes it very clear.
I think you've answered this one, but
okay.
Maybe you can do this as sort of an encore.
Okay.
So this is kind of maybe a grand reprise of what you just mentioned for the last hour. So if people are willing and able to accept the science of technology and use cell phones and computers and tablets, why are they reluctant to accept climate change?
Exactly. Well, I think we had a red slide on that. Do you guys remember? Yes? Yeah. This one, yes. It isn't a problem with science. It's a problem with the implications of the science for our personal lives. And that example I just gave you before was real. A year or two ago, I spoke to a group of water managers in South Texas. Conservative people, not really necessarily on board with the whole idea of climate change, but we walked through a lot of the information on trends, causes, futures. And at the end, most people were nodding along. And a man at the back stood up and said, very honestly, you know, I was not sure about this whole thing when I came tonight, but everything you've said made sense. My problem is, and he said what I just said to you, he said, my problem is I don't want the government telling me how to set my thermostat. That's the problem we have, but it's a lot easier to say it isn't a real problem than to say I don't want to fix it because it costs too much. It might cost me, I think, my personal comfort. It might cost me my lifestyle. It might cost me actually having to recycle or change my light bulbs. Or it might cost the economy. I'm afraid other people will get ahead of us, or the job market will tank. We're afraid it's going to cost us all these things, but what we don't realize is the clean energy economy is already on the way, and trying to stop it is like trying to stop a boulder rolling downhill. China is already leading the way, and the United States right now, in trying to shore up the coal industry, where jobs have been dropping for decades already, it's like trying to go back to the horse-drawn carriage after Henry Ford has already built his assembly line and is rolling out Model Ts. So you might say, well, if the clean energy economy is already here, then what's the problem? Let's just sit back and wait. The problem is that we have built up so much carbon in the atmosphere that we are already seeing the changes today, and if we let things happen at their pace that they're at today, we will be so far along the line that we will see some very serious and potentially dangerous consequences of climate change before we wean ourselves off fossil fuels. The issue we have today is a matter of speed. We have to do this faster. We're already on the way, but it has to happen faster or it will cost us in the end.
So, before I ask everyone to thank you, I'll give you a chance to just, if you want to end on a positive note.
Oh, yes, I would love to. Thank you, yes. That was sort of positive. We're on the right direction, yes. And China's leading the way, which is not something you would expect to hear 5 years ago.
Okay.
But no, you want something else
No.
positive?
No, that's positive enough. I think we can bond on that one, and it was quite inspiring, so thank you very much.